There exists an old text that influenced some of the most famous scientists to date, from the start of the scientific revolution with Nicholas Copernicus all the way to Albert Einstein. The book is considered a masterpiece in the application of reasoning to mathematics and also has gotten the reputation of being the most famous mathematical textbook of classical antiquity. I'm talking about The Elements, a book written by a man who is often referred to as the father of geometry. And this man was named Euclid, who lived in the city of Alexandria around 300 BC. This city was founded only 30 years earlier by a man who needs no introduction, the conqueror Alexander the Great, the ruler of the ancient kingdom of Macedonia. It is speculated that Euclid taught at the Mausoleum of Alexandria, which arguably included the famous Library of Alexandria, or the Great Library. The word Mausoleum is the root for our modern word for museum, which means any place that is dedicated to the muses, who are themselves the goddesses of science, literature, and the arts in Greek mythology. There's also some speculation that Euclid taught at this place after studying at the Platonic Academy in Athens, which was founded by Plato around 90 years before Euclid's time. And also Aristotle, the tutor of Alexander the Great and the student of Plato, studied at the academy for about 20 years. If this is all true, then Euclid sure had some big shoulders to stand on, and all the knowledge of his predecessors about mathematics and geometry he put into this 13-volume book called The Elements, which is available to us 2300 years later. Now, to put into perspective just how influential this book really is, it set the standard for geometric instruction that persisted for more than 2000 years. And other than the Bible, it is studied, translated, and published more than all the other books produced in the Western world. After all these years, it was discovered that Euclid's elements could also be applied to curved geometry instead of flat geometry. In the 19th century, mathematicians Carl Friedrich Gauss and his student Bernhard Riemann worked on this matter, resulting in the development of Riemannian geometry, where geometry could be both multidimensional and have curved and straight parts. This in turn set the stage for Albert Einstein's theory of general relativity, because it turned out that the theory of Riemannian geometry could be used to describe the behavior of spacetime. Euclid's Elements can be read as a puzzle book, each proposition or theory being a different challenge for the reader. The original text starts out with 23 definitions, after which 5 postulates and 5 common notions are given. The 5 postulates can be regarded as the rules to solve the great puzzle. If the postulates are inherently true, then logic dictates that also the propositions or the theories in Euclid's Elements must be true, which is either shown through proof by contrapositive or proof by contradiction. In the upcoming lecture series, I aim to rekindle the interest in the elements to the best of my ability. First, we will go through the rules to solve the great puzzle of the elements. So I will go through the definitions, through the postulates, and I will go through the common notions. And after this, each video will contain the explanation of about 10 propositions until the end of book 1. I hope you enjoy the journey that we are about to take together, and I will see you in the next video.